And on behalf of ERP Suites, let me welcome you to the first webinar in our Find Your Cloud series featuring AWS. As I mentioned, we have a lot to share with you, so I'm going to jump right in. Just a little bit about us in case you're new to ERP Suites. We're a comprehensive technology solutions company, and we've been providing cloud services and JD Edwards managed services for a little over 15 years now. But above all, in all we do, we strive to help our customers realize IT's potential from improving efficiency and increasing margins and other business goals. And our speakers today are Frank Jordan, Paul Scheer, and Josh Tibbs. And they collectively represent a combination of our advisory practice and cloud services. A quick look at our agenda. We're going to start with just a 10,000-foot view of AWS before taking a deeper look at some of the benefits specifically for JDE in terms of performance and resilience. Then we'll wrap it up with a look at database and licensing implications that everybody should certainly be aware of. It's probably the most important thing to be aware of when choosing your cloud. With that, we'll kick it off with Amazon Web Services, or AWS as we all know it. And Josh, I'll let you get started.
Hey, thanks, Diane. Appreciate that. So just a little AWS fast facts for those that may not be aware. AWS has been around as a platform for about 20 years. It's 2002. It was originally launched as a private platform for use within Amazon. And they kind of first opened that up to public use in 2004. And sort of relaunched as the multi-service platform, kind of as we know it today, in 2006. So it's a platform that's been around for a while, and a lot of times people don't realize that. AWS is huge in this space. You can see the figures here on the page, 13.5 billion in operating profits in 2020. That's 63% of Amazon's total operating profits, which is just absolutely amazing when you're thinking about that in the context of their e-commerce business. That Amazon's business is 63% cloud. It's absolutely amazing. They own 32% of the growing $150 billion cloud market here. They're followed by Azure, Google, Oracle, and you can see by adding up those numbers that Amazon AWS is really kind of the preeminent provider in the public cloud space. So that's why we're really happy to be partnered with them.
So thanks, Josh, for that overview. Before we get into the rest of the detail, I wanted to talk about some of the misconceptions that you had brought up earlier when we were talking. What are some of the common ones that you run into when talking about AWS?
Yeah, there are a couple of key ones here, Paul, and one that we see is the misconception that AWS is only for the so-called cloud native workloads, the cloud-born, high-scale type of workloads, and not really fit for enterprise workloads on Windows. And AWS, the truth is, AWS supports and runs Windows very well, so no problem there. And the other common misconception is that Windows is very expensive to run on AWS, maybe compared to some other cloud platforms. And customers often compare that AWS price to the Azure price with the hybrid benefit. And what they often don't take into account there is that that hybrid benefit is part of their enterprise agreement with Microsoft that's funding that.
So when they're doing the analysis, they need to take the cost of that VM with that hybrid benefit and then add in the dollars that are being funded through the EA agreement to really get their bottom line number.
Yeah, right. Exactly, Paul. You really need to examine this as a full TCO.
So what happens when we do that math?
Yeah, so they often find that the AWS price is very similar.
So what about using AWS instance types with fractionalized processors and burstable capacity, something like the T3 family?
Yeah. So let's take a look at what those T3s are. So those are the lower cost general purpose burstable machines. They deliver a great economy for spiky workloads that don't need that always on high performance. So kind of think about it in the days of buying a cell phone plan when you could buy an unlimited plan or a plan that has a certain number of minutes that match your usage needs. So kind of like that, right? So you could pay for 44,000 minutes a month or the entire month of minutes, but you're not going to be on the phone for that whole time. So this is kind of that same idea. Pay for a level that matches how much that you need. And then we have this concept, again, kind of like the cell phone plans of the old days where we have the rollover minutes. And those are CPU credits in the T3 world. So that's kind of how that works. And so if we look at the instance types in the T3 family, and we have a chart up here that shows some of those, each member of the T3 family has a baseline number, and that's where you can effectively run your full utilization of a vCPU for a certain percentage of time. So in this chart, we look at a T3 medium as an example, and in that one, if we run both vCPUs at 100% for 20 minutes an hour, that gets us at a zero balance, and that's what we're able to do. So if we kind of look at the CPU core or the CPU core fractionalization, here's kind of a graphic that demonstrates that bucket concept a little bit. So our T3 example, where we're using the CPU at 20%. If we use it less than 20%, we build up credits, aka filling the bucket. And if we use it more, we start to use the credits we may have accrued, and we sort of start to drain the bucket out in that instance. So there's a little bit more nuanced detail to it than that, but it's a really effective way of managing cloud computing costs for certain workloads.
Yeah, from a JDE side, that works well for certain workloads like non-production servers, the deployment server, because you only build a full package every so often, and even some WebLogic servers, where most of the time the CPU usage is going to be low because they're just not being used all the time.
So would this be a good option for fat clients as well?
Yeah, this would work for fat clients as well. However, there are also the options of AWS workspaces that might be a little bit better fit. But we like to work out the options with our customers and try to sort of figure out what's best for them.
So what do the overall economics look like for a T3? I remember the M5A you were showing before was around $132 a month.
Yeah, so if we look at that in the T3s, that price drops by about 39%. So now we're looking at going down from 132 down to $80 a month. And keep in mind too, these are all on-demand rates with no commitment. So if we start talking about 3-year commitment term, for example, that price would drop to around $40 a month.
Hey Frank, any thoughts about this?
No, not really. I'm not the cloud guy. I'm JDE guy, so give me something fast and enough resources to run it.
Nice segue to our next topic, Frank. So one of the main things that JD Edwards users are looking for is just the bottom line speed of the application. So Frank, what should we be concerned with when we're trying to achieve blazing fast performance?
So, for JDE, the two main bottlenecks are the speed of the database server, and then also what the single core clock speed is on your enterprise server.
Now, on the enterprise server, even if I don't have high clock speeds, couldn't I improve performance by just adding additional CPU cores?
No, not always. Thing to remember here is that a UBE only is a single process, so it can only go as fast as whatever that CPU core, like a single core, can do. So if you have faster clock speeds and you're doing a lot of CPU-heavy workload, it's going to take advantage of it.
Makes sense. So going back to the database server, what items affect speed there?
Well, again, the two main things there, it comes down to the RAM and the speed of the storage to pull up that data.
What about the speed of the CPUs on the database server?
In the majority of cases, CPUs really doesn't matter that much.
So you want as much RAM as possible with as few CPU cores as possible?
Yep.
Wow, sounds like a great opportunity for limiting license exposure. But let's come back to that one in a little bit. Josh, Frank mentioned the speed of the storage on the database servers. Any thoughts here?
Yeah, so let's talk about storage on AWS for a little bit. So when we're talking about storage, particularly around JD Edwards and our EC2 instances, we're talking about block storage. This is kind of the direct attached or SAN type storage that we've known and loved for a long time, and AWS delivers this as EBS in a few flavors. And the main options here are your IO and GP. And so your GP3 is the latest generation of the general purpose SSD backed storage. This is great for lots of types of workloads. It allows us some scaling opportunities between performance and capacity to some degree, and allows us to tune it to the needs of the workload. But when we really need to crank up the performance, we can turn to IO2, which is the latest in generation of the provisioned IOPS service. And this service gives us even higher performance and data durability. So this is as much as 4 times performance per volume versus the GP3.
So it sounds like you can give Frank exactly what he needs for his database server.
Yeah, big time.
So how do the economics work out exactly? So let's say that Frank needs 400 gigs of storage with 12,000 IOPS. Frank, 12,000 IOPS enough?
Well, from my perspective, there's no such thing as enough IOPS for the database, but yes, at least 12,000 generally is going to work well for a number of customer workloads.
So Josh, how would the economics of that work out with IO2?
Yeah, it's a great question, Paul. So let's go through a couple of ways to do that. So with IO2, we would provision that 400 gig volume with 12,000 provisioned IOPS. That gets Frank exactly what he was looking for. And that's pretty straightforward, monthly cost of $830.
Josh, I just grabbed my heart. $830 for 400 gigs, that is outrageously expensive.
Yeah, don't worry, Paul. We probably wouldn't use IO2 in this situation. There's actually a better option. So we could use GP3. We would provision that 400 gig volume with 9,000 IOPS. So note we only had to provision the 9,000 IOPS. These are additive. The GP3 volume comes sort of packed with 3,000 IOPS in there already. So this would only cost about $77 per month.
Wow, that IO2 is a lot more expensive than GP3.
Yeah, and we can even do better with the GP3. So if we leverage some of the qualities of the GP3 here. So since each volume comes with a 3,000 IOPS, as we mentioned in our last example, regardless of the size, we can actually just provision 4 volumes to get to our 400 gigs. And we don't need to add any additional provisioned IOPS. So that gives us our 12,000 IOPS between the 4 volumes that make that up in aggregate.
So from $830 to $32 a month, that's pretty impressive. Given that this database, given that this is a database server, do you have any concerns about splitting up the disks that way? If you do, if you take a snapshot of those and you try to return them or restore them later, are you going to end up with a problem of inconsistencies between the snapshots where your database won't come up?
No, not an issue. We just make sure that when we provision them, the volumes, we select consistent snapshots. And that's actually a great example how we bring our knowledge of the cloud platform and the needs of the workload together and get the best value for the customer.
So Josh, how would you go about satiating Frank's need for raw clock speed on the enterprise server? Yeah,
Frank is in luck here. AWS has the fastest clock speeds of any of the hyperscale clouds out there today. The M5ZN, as an example here, can turbo up to 4.5 gigahertz. So you'll see here that this is significantly faster than the comparable VMs on some of the other cloud providers. They're offering clock speeds in the high 3 gigahertz range, and that's amazing. But in a sea of amazing clock speeds among the cloud providers, AWS really brings the holy crap 4.5 gigahertz turbo speed.
Yeah, for me, batch and call object in different workloads, they could really leverage those higher clock speeds. Give you a quick example, like financials, MRP, calculations, some of the new real-time summarizations that are very CPU intensive. Having that extra headroom really helps in a number of situations.
So we've talked about performance. Let's move on to resiliency. So Josh, when we were talking earlier before the webcast, you had mentioned the importance to differentiate between in-region recovery and traditional disaster recovery. Can you describe for everyone what the difference between those are?
Yeah, I'd love to actually, because this is a sort of an important core concept to understand with AWS. And so let's talk about those key concepts here. So a region is a geographic area. So think about that as a metro area. And an availability zone is a physical center that provides the infrastructure resources within that region. So kind of think about that as a data center within that metro area. So with AWS, you can leverage this to protect service availability in a region with another availability zone. Usually it's pretty easy to do. So you don't have to think about the snapshots and the copies and the replications and the IP changes and RTOs and all those other things that you go into thinking about in a typical DR kind of scenario. Now, on the other hand, if you have availability requirements that are driving a more geographically diverse availability posture, we can use AWS regions to deliver that too.
Yeah, it's important to note, for optimal JDE performance, you really want to have everything, though, running in the same availability zone. Yeah, again, you can have 2, 3 availability zones in one region, and that response between the AZs could be sub-millisecond, but JD Edwards really prefers it to be in the microsecond range. And because JD is very chatty, that adds additional latency, which essentially can slow JD Edwards down.
Yeah, for sure, Frank. You want to try to architect that into the availability zone to get the best performance whenever you can. But recovery into another AZ when you need to do that is pretty fast. So you can recover from object storage. And most of the volume sizes that we're usually talking about for these JDE workloads are small. And the exact recovery time is sort of dependent on the size of the volume. So the larger the volume, the more time it takes. And so we actually use that to our advantage in this situation with the smaller volumes. We can generally recover more quickly.
So does the same thing hold true with outer region disaster recovery?
Yeah, for the most part, it's important to note there are additional details, like I mentioned before, that you need to start taking into a full DR scenario, right? There's architecture, setup, networking that you need to bring in and to get into a different region, but it's all very achievable.
So all of this is great when we're talking about small volumes, but what if I've got a really large database server and I really need a very low RPO and RTO?
Yeah, so that's a great question. So those examples we talked about, they work for databases as well, but many customers with the larger databases can't afford the time to recover from object storage, the time that would take. So Amazon's RDS provides a way to do this to kind of give you HA between availability zones for Oracle.
So is this Oracle Data Guard that you're showing?
No. In fact, RDS for Oracle works by doing block storage replication between the AZs. So that's fully an infrastructure function. So no feature from Oracle involved here and no additional licensing required to do that.
So does that work on standard edition? Most JD Edwards customers running Oracle database, they're using standard edition too, since it's bundled in to the JDE Oracle Tech Foundation license?
Yeah, it does. And in fact, AWS is the only cloud that I'm aware of that offers a native HA solution between the AZs for Oracle Standard. For disaster recovery, Amazon supports cross-region backups and all does this with snapshot and transaction log replication.
So what about SQL Server?
Yeah, so RDS is available for SQL Server, but we tend to find best practice for JDE is to often run SQL on an EC2 instance, and when we need to bring higher availability, bring better HA into the mix, we use always on clustering there.
Yeah, from my JDE technical side, you need to log into the SQL Server directly, which with RDS, that's a challenge during the initial install phase, is really what our issue is. We had some of this back in the days with Oracle a while back, but you know, there's ways around it. It is definitely takes a little bit more effort. Usually if we have to do it, we'll install it to a server and then migrate that server into the cloud if we really had to, push comes to shove.
So Frank, kind of regardless of whether we use SQL Server on RDS or we do always on clustering directly on top of the EC2 instances, what does the recovery process look like if a failover happens? So everything's running on one node, it dies and fails over to the other node. What do you have to do to get JD Edwards back?
Pretty straightforward. You basically just have to bounce the services on, you know, your E1 services, like your enterprise web servers and so forth, to get everything running or to reconnect. The best practice within that, though, is you can also have automated orchestrations to do that bounce, you know, to take it down and then to bring them back up.
So Josh, we've been talking a lot about Oracle and SQL deployments on AWS. Can you spend a little bit time talking about the database licensing and how that works when utilizing AWS?
Yeah, so this is the number one thing you need to pay attention to when you're picking cloud. So this is an area where if you can get it wrong, it makes the cost of the infrastructure just look like a rounding error. So critically important to pay attention to, and we can get into some of those details here, Paul.
So Frank, you had mentioned earlier that most, or at least a lot of the JD Edwards customer base is running Oracle database today.
Yep, I mean, that's the good news. You know, if you've got the Oracle Tech Foundation as part of your JDE license and you're deploying Oracle Standard Edition 2, you really don't have anything to worry about the licensing there. Since this is licensed by user, it doesn't really matter on how many processors you deploy it on. If you have it, basically it's a sunk cost. You're already paying for it, and you really don't have to consider it. You know, there are restrictions, though, about how you can use it, but again, we really don't have enough time today to get into those details.
Okay, so that would be the user base with the Oracle Tech Foundation license. Josh, how would that work if a customer had processor-based Oracle licensing? More good news?
No, that's not good news, Paul. In fact, I don't know how I always get to be the bearer of the bad news, but yeah, here it is. AWS and Azure too, for that matter. The x86 processor core factor is not applied.
So what exactly does that mean, Josh?
Yeah, so in an example here, if a customer needs 16 vCPU of Oracle licensing, they're going to need to buy twice as many licenses on AWS as they would if they ran that same workload or same Oracle workload on Oracle Cloud or even on-prem.
Ouch. Where are those antitrust regulators when you need them?
Yeah, exactly.
Any idea on the type of dollars that we're talking about here?
Yeah, lots of them. It gets expensive really fast. So on AWS, licensing those 16 vCPU, you're looking at about $380,000 upfront and around $83,000 in annual support. That's, you know, like we said, that's about twice as expensive as running it on Oracle's cloud.
So what can we do for customers that are still wanting to run this on AWS to help contain these costs?
Well, remember I said before, you know, JD Edwards database servers don't really require much CPU, just lots of RAM and fast disk.
Yeah, so this is where an X1E might be a good option. So this has sort of the best ratio of CPU to RAM of any of the AWS instance types. So the X1E X large has 4 vCPUs, and you get 122 gigs of RAM. And the X1E 2X large has 8 vCPU, and you get 244 gigs of RAM. So the one thing you need to be mindful of, though, here on these instance types is the EBS, and that's the block storage. Again, the bandwidth there. So an X1E large, it's limited to about 500 megabit per second. A 2X large limited to 1,000 megabit per second. And so you really need to make sure that you understand your database I/O characteristics before you choose this instance type. One interesting note here, just a side note, this instance type has local NVMe with the instance. So for SQL Server, for example, you could leverage that, put your temp DB on it so you don't hit the EBS storage and ding that bandwidth. And it just gives you kind of a local cache effect if you can do that way.
So could we just select something like a Z1D 6X large and then constrain the CPUs down to 4? That would give us like 192 gig of RAM and 9,500 megabytes per second bandwidth, EBS bandwidth. That's like 10 times faster than the other option.
Yeah, so technically that would work. It's a risky strategy concerning whether Oracle would accept that method of constraining the CPUs is valid if you're in an audit situation.
Makes sense. Back during the on-prem days, I actually had a customer that required us to open up a server and physically yank the CPU, one of the CPUs out of it, because they were worried that disabling that CPU and BIOS would be insufficient if an audit happened.
Yeah. The bottom line, though, is you need to do a deep dive on the usage pattern, game out the best option. That's where we can help, and it might help to get good lawyers.
So speaking of anti-competitive things, how about what Microsoft did with AWS regarding SQL Server licensing?
Yeah, so in November 2019, they effectively killed the bring your own license for SQL Server.
So effectively, what exactly do you mean there? Sounds like there might be a little bit of wiggle room.
Yeah, so I mean, you can still bring your own SQL licensing, but to do it, you need to use a dedicated host, and that's not always the right answer for every customer. Note this doesn't mean you have to use a dedicated host to run SQL. You can certainly run SQL using a SQL license included SKU or instance type from AWS. That's just a change to that one method of licensing. So another thing, though, that you can do is use Developer Edition for your non-prod database users or database servers, excuse me. That's free, and we can help you get through all of those sort of Byzantine license regimes with regard to the public cloud stuff with the database vendors and the other software vendors, and try to get you to the best value for your workload.
Thanks, Josh and Frank, for the insight that you've given us today. Looks like there's a lot of good deployment options out there for JD Edwards. AWS, as we just covered, and then Azure, OCI, and private cloud we'll be talking about in the future. Which one of these clouds is right for your organization? What are the trade-offs? We'd love an opportunity to help game out these options for you. Email us at findyourcloud@erpsuites.com with any questions or to schedule a free assessment. On behalf of the entire ERP Suites team, thank you for attending.